Welcome. Is there life on Mars? Mars was once a habitable planet with lakes and oceans. One of the main goals of the Perseverance rover is the search for ancient microbial life on Mars. One of the instruments on board the rover that would help in this search is the Supercam. The Supercam is mounted on the mast of the rover. If we look at the head of the mast, we see a pair of Mastcam Z cameras as well as a pair of navigation cameras. Just above these cameras, we see a white box with a big eye. That is Supercam. When we look inside the box, we see something like this. Supercam is a complicated instrument and is actually a combination of 6 different remote sensing instruments that will analyze the mineralogy and molecular structure of the rocks and sediments for clues of past life on Mars. The first instrument is the Light-Induced Breakdown Spectroscopy, or LIBS. This instrument is similar to the ChemCam LIBS on the Curiosity rover, but is faster and more powerful. It fires a red laser on a target as small as a mosquito up to a distance of 7 meters. The laser instantly vaporizes the point target, turning it into very hot ions or plasma. The instrument then captures the different colors or wavelengths of the light emitted by the plasma, which reveals the elemental composition of the material. The laser also creates a shock wave that blasts away the surrounding dust, thereby clearing the surface of the rock to be subsequently analyzed by the other instruments. This is a stone or rock on Mars that was targeted by the LIBS instrument, and we see the numerous holes that was created as a result of the material being vaporized by the laser. LIBS usually performs spectral analysis on a series of points arranged in a line or grid, also known as a raster. Here we see an example of the atomic emission spectra taken by the LIBS instrument and shows the different peaks corresponding to the different elements like iron, silicon, magnesium, zircon, titanium, and so on. LIBS can quantitatively analyze at least 25 major, minor, and trace elements. It can also detect the quantity of hydrogen, which is important in knowing the state of hydration of minerals and soils. The second instrument that comprises Supercam is the Raman Spectroscopy instrument. This is the very first time that a Raman spectrometer has flown in space. If we look back at this figure, we see a red laser and a green laser beam. The ChemCam laser on the Curiosity rover only has the red laser of the LIBS instrument. The major upgrade on the Supercam is the addition of the green laser. This is a 532 nanometer pulsed laser light and is the one used by the Raman spectroscopy tool to remotely investigate objects up to a distance of 12 meters. In this technique, some of the green laser interacts with the molecules of the target, resulting in a shift in the wavelength of the scattered light. This change in wavelength is proportional to the lattice vibrational energy of the molecular bonds. The spectra of this Raman scattered light is unique for its molecule, therefore serves as a fingerprint and enables the identification of mineralogical composition of the target material. Whereas the LIBS instrument detects the individual elements like iron, magnesium, etc., the Raman instrument determines how these elements are combined together into minerals and molecules. It can detect carbonates, sulfates, silicates, phosphates, and many other mineral species. Very importantly, it can also see organic molecules such as aromatics, carotenoids, and amino acids. This is an example of spectra of organic molecules as seen by the Raman Spectroscopy instrument during testing on Earth. We see the fingerprints of methanol, benzene, and cyclohexane. This instrument will be crucial and will play a pivotal role in the search of biosignatures on Mars. For the first time in our lifetime, in our generation, on another planet, we now have the capability to detect the ingredients of life.